So today we are looking at how we can use matrix inversion to solve a simultaneous equation. So this is how we go about it and we begin. So when you have a problem like x plus y is equal to 5 and x minus y is also equal to 1. This is how we go by it using the matrix inversion. So we have the general equation system. So we say the equation now the equation system that we will use to solve this is ax equals b. Now with this ax equals b, what we mean is that this a here is representing the matrix. So it means we have matrix A, and then x here is also representing the variables we have in the equation system, and then b here is also representing the 5 and the 1 here, what we have after the equation sign. So that's what we are going to do. So from this we can say that A is equal to now the matrix here represents the coefficient of the variables. So here you can see that the coefficient of x here is 1. It's written here. The coefficient of x here is 1. The coefficient of y is 1. Let's not forget that the sign here is negative and it is attached to the variable or the coefficient of the variable y. So we still have minus 1 here. And this is matrix A. So you can also see the x is representing the variables. So it's also equal to x, y. So you also have x. And then the y is the numbers after the equal sign. So we have 5 and 1. Sorry. This is B. So this is the criteria we need to solve the equations. Now we said we have ax plus b. Ax is equal to b. So this is A, which is matrix A. This is x representing the variables, and this is also B. So with here, what we're going to do is that now before we can solve for that, we have to make this x the subject here because we are looking for the variables. So to look for the variables, so make x the subject. We are making x the subject in ax equals b. So you're making x the subject in this one. Now you're going to get x is equal to A inverse of b. The reason why we are having this is that to make x the subject, you divide through by a. So under normal circumstance, we should get x is equal to b over a. But in matrix, we don't have over. So any number over, it means the inverse of that number. That is why, so we take it as x is equal to a inverse This is the A inverse. Then you multiply it by B. This is X. Meaning, we also getting another problem that we need to deal with. You have to find the inverse of A. So to find the inverse of A, you first have to find the determinant of A. So we have A as this. We know our A to be 1, 1, 1, neg 1. So we have to find that A, and then that A, which is 1, 1, 1, neg 1, 1, 1, 1, neg 1, will also be equal to, so we will have that A to be equal to, that A will be equal to 1 times negative 1 minus 1 times 1, which will be minus 1 minus 1. So that which will be equal to minus 2. So therefore that A is equal to minus 2. Now we have that A to be equal to minus 2. So we have to find the adjoint. Now let's not forget our A is 1, 1, 1, neg 1. So we are finding the adjoint of this. So our adjoint which is as adjoint of A will be equal to, now with the adjoint you only have to interchange the positions of the leading diagonals, then you negate the other diagonal. So what you do is, so negative 1 will come here, then the 1 will be this side. So we have negative 1 here, and here to be 1. So you have negative 1 here and 1. Then you negate. So you have neg 1, neg 1. This is the adjoint. So you have the adjoint to be this. Now the next thing we will do is that now A inverse is equal to 1 over that A times adjoint of A. A inverse is equal to 1 over that A times the adjoint of A. So we are getting A inverse to be 1 over minus 2 times the adjoint, which is neg 1, neg 1, neg 1, 1. This is it. And it will be equal to negative 1 over 2 times negative 1 will give you minus positive 1 over 2. Negative 1 over 2 times negative 1 also give you 1 over 2. Negative 1 over 2 times negative 1 will give you 1 over 2. Negative 1 over 2 times positive 1 over 2 will give you minus 1 over 2. So therefore this is the inverse of A. So let's not forget A inverse is equal to this 1 over 2, 1 over 2, 1 over 2 minus 1 over 2. This is A inverse. But remember we said x is equal to A inverse times B. So to find the variables, x will be equal to A inverse, which is 1 over 2, 1 over 2, 1 over 2 minus 1 over 2 times B. Don't forget our B was 5 and then 1. So our x will be equal to half times 5 will give you 5 over 2 plus half times 1 will give you 1 over 2. Half times 5 will give you 5 over 2 plus minus half times 1 will give you, so this minus, okay, so it will be minus 1 over 2. Let's take it this way, and it will be equal to this plus this. The LCM is 1, so you get something like this. There you have the LCM to be 2, so you take 1, so which is over 2, then you add the top, which is 6, so you're getting 6 over 2 here because of the minus sign. So you get 5 minus 1, which is 4 all over 2, and you are getting 3 and then 2. So our x will be equal to 3 and 2. But you remember we also said that the same x is equal to x and y. So you can say therefore by comparison you realize that x is equal to 3 and y is also equal to 2. So by comparison you can say x is equal to 3 and y is equal to 2. So this is our final answer. X is equal to 3 and y is equal to 2. You can put these two variables, the values here, in the original equations and check if it is actually the correct answer, and you will see you will get it. So thank you for watching this video. Please don't forget to subscribe and also share the video. Thank you.